This instructional video is on the Student Companion, pages 12 and 13. In example number 1, Haley has 2 sisters and no brothers. Josh has 2 brothers and no sisters. They wonder what the chances are in a family with 3 children that the children will all be boys or all girls. How can they determine all possible combinations of boys and girls in a family with 3 children? So our first method is going to be used to create what is called a tree diagram, where we list out the possible combinations for each event. So for the first child, we know that they could have either a boy or a girl. Now from here is where the tree breaks apart. For the second child, again, they could have either a boy or a girl. So the tree would be read as boy, boy, or boy, girl, going from first child to second child. Same thing with the other tree. It could go a boy or a girl. So it could go girl, boy, or girl, girl, reading the tree. We solve it again for the third child in the family. So we break it down a third time, boy and girl, meaning they could have 3 boys, or they could have 2 boys and then 1 girl. We break it apart again, labeling the third child as either boy or girl, meaning it could go boy, boy, or boy, girl. Continuing breaking down the tree diagram, labeling the third child as boy or girl. So the order could go girl, boy, or girl, girl. And then the last one, we break it down again for the third child as boy or girl, meaning the order could go girl, boy, girl, girl. So since this is our final tree diagram, we've labeled all 3 children. Our total number of outcomes is our values across the bottom. There are 8 values across the bottom, so there are 8 possible outcomes. In our try it example, it says George will flip 2 quarters at the same time. Complete the tree diagram and then list the sample space of this compound event. Use H for heads and T for tails. So when you flip a coin, you can either get heads or tails for the first quarter section. When you flip the second quarter, you could get heads first and then heads again, or you could get heads first and then you could get tails for the second quarter. If you got tails first, you could then get heads for the first quarter, or you could get tails first and then tails for the second quarter. Again, your total number of outcomes comes from your final piece, in which there are a total of 4. And so there are 4 possible outcomes. Under Convince Me, it says, how does the sample space change when the number of quarters that George flips is increased by 1? Meaning, what if we flipped quarter number 3? If we flipped quarter number 3, we would break the tree diagram apart. So instead of heads, we could have heads and tails again. Instead of tails, we could have those values another time. Instead of heads, we could have those values another time. And instead of tails, we could have those values another time. Meaning our sample space becomes 8. Our outcomes change from 4 to 8 when you add another quarter. In example number 2, it says a game is played by spinning the 2 spinners shown. Players match the results of the spinners to the combinations on their game cards. How many different combinations are possible? So instead of a tree diagram, another representation would be to make a table. If you look at the red spinner lists out letters A, B, C, D, E, and F. And if you look at the blue spinner, it lists out numbers 1, 2, 3, 4, 5, and 6. So you can create a table of values using all of the information provided, and then you can match up the different combinations. So you could get A1, A2, A3, A4, A5, or A6. You could get the same values with B, the same values with C, D, E, and F. All the same process. You are listing out each of the possible outcomes that happens with both events. Once you fill out the completed table listing out all events from both pieces of information, you would then count up the total number of squares to find your total number of outcomes. In this event, you have a possible number of 36 outcomes. And again, to find that value, you would count up all of the information in the table that you created. The option is to use an organized list to represent the sample space. If Stan rolls a number cube labeled 1 to 6 and flips a coin, what are the possible outcomes? So he could roll a number 1 and get heads, or he could roll a number 1 and get tails. He could roll a number 2 and get heads. He could roll a number 2 and get tails. He could roll a number 3 and get heads. He could roll a number 3 and get tails, so on and so forth until we get all possible outcomes listed, which would be a total of 12 outcomes. For our triad example, it says the bag contains tiles labeled with the letters A, B, C. The box contains tiles labeled with the numbers 1, 2, and 3. June draws one letter tile and one number tile. Represent the sample space using either a table or an organized list. So if we list out our values for the tiles, we could have A1, we could get A2, or we could draw A3. If we draw the letter B from the bag, we could have B1, B2, or B3. If we draw the letter C first, we could have C1, C2, or C3. Those are all of our possible outcomes. So we have a total of 9 possible outcomes.